So, good morning, everyone. And this is our lecture number 14 for circular dynamics. We are almost to the end of this chapter and we will be winding it up soon enough. Let us have a quick recap of what we had done in the previous class. In the previous class, the previous 2 or 3 classes, we have been dealing with what? With motion in a vertical circle, and we had seen what is happening from A to C, the lowest point to the highest point. Velocity decreases, tension also decreases. When come down, velocity and tension both increase. Is everything okay on that side? Okay.
Can you hear me?
Yes, I can hear you. Everything is okay?
Yes, sir.
Everything is okay?
Yes, sir.
Great. So we had also seen that at lowest point, velocity, speed, and tension both are maximum. At the highest point, velocity and tension both are minimum. Right? We had also made a set of, I think, 16 equations. 16 equation, the last of these 16 were equation number 13 to 16, and these 13 to 16 were law of conservation of mechanical energy from A to B, A to C, A to E, and different points as such. And I told you that you don't have to be concerned about all these equations, because you don't have to make all equations in all cases. You just have to make 2 or 3
Sir.
out of these to
Hello.
solve any question. Yes, beta.
Sir, are we audible?
Yes, everyone is audible.
Okay, sir. Okay, sir.
Okay. So out of the 16 equation, we will not be using all 16. We will be using only which ones are required. Let us now not waste any time. We have wasted a lot of time today. Let us not waste any more time, and let us begin today's class. And as I told you in the previous class, that the most important factor that decides what is going to happen, what type of motion this body will have, it depends on one thing and one thing only. What is that one thing?
State point A.
Yes, that is the most important and the deciding factor that decides what happens to the motion, velocity or speed at point A. Now, so we will now think of what all can happen, what all types of motion can happen. Now, let me give you an example. Now, we have different regions. We have a blue region, which is extending from A to B. We have a green region which extends from B to C. So there are 2 regions specifically. The lower half, the blue one, and the upper half, the green one. Either the motion will be restricted in the lower half or the motion will go in the upper half. These are the only 2 possibilities that can happen. Right. Now, there is one more possibility, or in fact, 2 more possibilities that can happen. One is the body just reaches point B. The body just reaches point B. So that will be the middle point. The next case would be the body just reaches point C. That means I have 4 possibilities. Number 1, between A and B, it remains. Number 2, it reaches till B and then it moves in a semicircle from A to B, then back to A, then to D, then to A, then to B. The third possibility is it remains somewhere between B and C. What will happen in this case? That we will see. The fourth possibility is it just reaches point C. There is also a fifth possibility. It goes past point C. The sixth possibility, the fifth possibility, that it goes past point C, or the fourth possibility that it reaches point C. Once it reaches point C, in all probability, it will just go past the point C. We'll see all these conditions because all these conditions depend on one thing and one thing only, and that one thing is velocity at point A. Let us do case number 1. Are we all ready? Can I have some raised hands from everyone in the class that we are ready to start our operation? Are we ready, everyone?
Yes, sir.
Case number 1. And what is case number 1? Case number 1 is simply the body reaches point B. The body has to reach at least till point B, or it just reaches point B. Now the question is, what should be the velocity at point A for this to happen? If the body has to reach just point B, what is the speed at point A that makes it possible? Because everything depends on speed at point A. How will I find it out? Well, I'll give you the answer first. I'll do it in a different way. I'll give you the answer first. The answer for this is, if the speed at point A is exactly equal to root of 2GL, if the speed at point A is exactly equal to root of 2GL, then the body just reaches point B. How do I find it out? Anyone, any idea how do I do it? How do I do this?
By lock me, sir.
Yes, beta?
By lock me.
By lock में. Chalo. By lock में. We apply lock में. The first thing that we do is we apply lock में. From where to where?
From A to B.
Okay, as you say, I apply lock में from A to B. Tell me the lock में equation from A to B.
Half mv a square plus 0 equals to half mvb square plus mgl.
Okay. Well done. Now tell me. Now you have the answer. Now tell me, if it has to reach point B, just reach point B, what will be the velocity at point B? It just has to reach point B. What will be the velocity at point B?
0, sir.
0. Yes, 0. Our old friend 0. The velocity, what happened? The velocity at point B has to be 0. Now it becomes a straightforward answer, straightforward question with a straightforward answer. From this equation, lock me equation from A to B. Only one equation we have used and we are ready with our answers. From lock me equation from A to B, this is how we have to solve each and every question. Remember that, that is why I'm doing this. With lock me equation from A to B, we will get the velocity at point A, and tell me what is the velocity at point A coming from this equation? What is the velocity at point A coming from this equation? It will be coming as
root over 2GL.
root over 2GL. So with this velocity, if I push this body with root over 2GL, whether it is body attached to a string or body kept on the inner surface of a circular thing, it will just reach point B. Am I clear? Can I have some reason that we understand this?
Sure.
Okay. Now comes the supplementary questions. Supplementary questions. Can you tell me, since you know what is the velocity at point A, if you know velocity at point A, you know everything in the universe about this question that can be asked. Now, can you tell me two more things that I can ask here? I can ask here, what is the tension at point A? What is the tension? What is the tension at point B? How will you get those tensions? I've already given you the equation. Tell me the answer for tension at point A. We have already done the hard work. You now have to reap what you have sown in the past two classes. You reap what you sow. What is tension at point A? How will you get tension at point A? Just use those equations. Tension at point A. Can anyone recollect? I'm not going to write it again because
1 second, sir.
just 1 second. You should have used this 1 second before, bacha. I gave you so much time.
Three mg, sir.
Yes, look at this equation. Equation number 2, my dear friends. I'll not rewrite it again. Equation number 2, because I want you to recollect what we have already done. Equation number 2, look at equation number 2. TA minus mg. We have written this equation so many times. TA minus mg is mva square by L. We know the value of va square. Va square is 2gl. You cancel out the common terms. And and you end up with the answer, and the answer would be 3 mg. Do we all understand this? Can I have some raised hand that we understand this? Tension at point A would be 3 mg. Cam is not working, doesn't matter. You can hear me, you can see me, doesn't matter. The next question is, what is tension at point B? And I'm still waiting for your answers for tension at point B. Tension at point B. Tension at point B. Anyone with an answer? Anyone with the answer for tension at point B? Which equation should I use? Already written those equations here. Equation number 4 is what we are looking at. The blue one, which I'm marking as blue.
Be 0, sir.
Yes, it is going to be 0. It is going to be 0 if the velocity is 0. Tension at point B will also come out to be 0. So here I write all the things that could be asked in this question. Tension at point A is 3 mg. Velocity or speed at point A is root over 2gl. Velocity or speed at point B is 0. As you can see, both the velocity and speed at point B is becoming 0. This is the condition when the body just reaches point B. Do we all understand this? Do you understand this?
Yes, sir. Yes, sir.
Have you noted this down? Everyone, I'll give you a second to note this down, and then we will move on to case number 2. Case number 2. So now, what I have in my hands is I know one speed, which is root 2 GL. If I give that much speed, it reaches point B. Using common sense, now can you tell me what would be case number 2?
Body
What would?
reaches point C.
Okay. Yes, that could be easily case number 2. Yes, I agree on that. But see, I always do things systematically. So I am at the lowest point. I find the condition that it reaches midpoint. Now, what should I think about logically? Should I consider the highest point first, or should I consider something else first? I should consider the case where VA is less than root 2 GL. Does it make sense? Does it make sense that I now see what happens if I give it a lesser velocity than root 2 GL? What will happen then? If VA is less than root 2 GL, the body does not what? Does not what? It will never reach point B. The velocity or speed will become 0 between A and B, and it will remain in the lower half. Do we understand this up till here? Do we understand it between up till here? Yes or no? Do we understand it?
Yes, sir.
Tension never becomes 0 because it is in the lower half. Remember, in the lower half, tension will never become 0. This is the condition where the body remains in the lower half. Nothing happens. Nothing happens. It cannot reach point B. It will just remain moving like this. Give you time to note this down, and then I will give you a problem where we will try to understand if it is less, what happens. So you can note it down. Till then, I will write the problem. I hope everyone has noted this down. Yes or no?
Yes, sir.
Then comes this question. Now, what happens in this question? At the lowest point, A, I have given it a velocity root of GL. My first question is, will it reach the point B?
No, sir.
It will not reach point B. Well done. It will never reach point B. So it will stop somewhere between A and B. Yes or no?
Yes, sir.
Let us say that this point E is the highest point it reaches. This point E is the highest point that it reaches. We have to find out the unknowns. What are the unknowns? Find angle theta, find tension at point A and tension at point E. This is the question. I will give you a minute to solve it. How do you solve it? You already know how to solve it. I have given you all the arms and ammunition that you require. I'll be back in a minute. I hope I am welcomed with answers. My dear friends, anyone with an answer? Anyone with any thoughts?
Sir, TA equals to 2 mg.
Okay, so I have the first answer. TA. How do I get TA? This is TA. This is mg. You will make the equation for the centripetal force. TA minus mg is mva square by L. That is correct. From
Yes, sir.
there, you will get the value of TA as 2 mg. Well done. So far, so good.
T equals to mg cos
Yes, beta.
mg cos theta.
TA is equal to mg cos theta.
mg cos theta, sir.
TA is equal to mg cos theta.
TE.
TE. How do I get TE? Let us first draw the diagram. TE. This is mg. What is the velocity at point E? First, tell me what is the velocity? Zero, because it will reach the highest point here. Velocity at point E is zero. If I make the equation for TE, it will be TE minus mg cos of theta will be equal to m into v square by L. Yes or no?
Yes, sir.
But we know that this VE is equal to 0.
0.
So I get the answer of TE. TE is mg cos theta. But do I know the value of theta? Do I know the value of theta? The value of theta is not known. So this is still not an answer. I've got the value of t in terms of theta. If I know theta, I will get the value of t. If I know t, I will get the value of theta. So the only question is find the value of theta. How will I get the value of theta now? That is the question. How will I get the value of theta? Anyone with an answer? One more minute. Think about it. I want you to give me an answer. I'll wait for your answer for 1 minute. Sorry. So how do I get the value of theta? No one knows it. How do I get the value of theta? No one knows it. That's very sad, because I just have to make no one knows it. How to do it? One last chance. Okay. No one knows it, so it's my job. to let you know. And you have to make equation number 15, which is log me from A to E. That is the only thing that is left in this question. You have to make log me from A to E. The equation is right in front of your eyes. We know the value of velocity at E is 0. Velocity at point A is root over GL. From this, you should be able to find out the value of cos theta. Am I clear? Is everyone there in the class?
Sir.
The equation is right in front of your eyes. The yellow equation, that is the equation that you have to make. I am not going to do it for you now, because the more I do it for you, the more lazy you seem to have become. And only two things that I've told you: make the equation for tension, make the equation for log me. If you only do half of the job, you'll only get half of the marks. So now you have to make the equation for log me. That's right there on your screens. Make the equation, get the value, and get me the answer. What is the answer? Tell me. From that log me equation. From the log me equation. What is the answer? Half m va square is
Cos
equal.
inverse of 1/2, sir.
It should not have taken so long, bacha. Plus mgl into 1. I would have been very happy if you could have done this on your own. Even now I am happy, but not so happy. From here, putting the values, you will get the value of cos theta as half. I hope most of you have got this. That means my theta becomes 60 degrees. So it will rise up to a height of 60 degrees. As soon as I know theta is 60 degrees, I can write it here. The value of tension at point E becomes mg by 2. Am I clear with this question, everyone? Do we understand this? Can I have some raise hand that we understand this? So you cannot raise your hands. Can I have some confirmation from your end that we understand this? Okay.
Yes, sir.
That is how you do it. The same pattern repeats for any question. For all of the question, this is how you do it. Now, let us, I hope everyone has noted this down. Now, let us move our attention to case number 3. What would be case number 3? I hope everyone is noting it down. What would be case number 3? What would be case number 3? Anyone? What would be case number 3? Case number 1 was velocity was root over 2gl. I reached point B. Case number 2 was velocity is less than root 2gl. I go somewhere between A and B. What should be case number 3? Anyone? Just reaches which point?
C, sir.
Just reaches topmost point C. That is my case number 3. Now, what should be the conditions? What would be conditions to reach point C? What should be the first condition to reach point C? The first condition is tension never becomes 0 between A and C. Yes or no? Do we agree on this?
Yes, sir.
Why? Because if tension becomes 0, then what will happen? If tension becomes 0, what will happen? If tension becomes
Point does
0,
not reaches C.
it will leave the circular path if tension becomes 0. If tension becomes 0, it will leave the circular path. There is nothing to keep it moving on the circular path. Yes or no? Do we understand this? Do we understand this? To just reach point C, the condition is tension at point C just becomes equal to 0. That is the condition to reach point C. It should continue its travel till point C. To continue its travel till point C, tension should not become 0 at any of the points. In fact, to just reach point C, tension at point C can just become equal to 0. Can we have some raise hand that we understand this? Point C, velocity or speed never becomes 0 between A and C. If velocity becomes 0, it will stop somewhere. To just reach point C, what should be the velocity or speed at point C? Tell me.
0, sir.
0. If tension at point C is 0, will that mean velocity at point C is 0? There is only one point.
Sir.
There is only
point.
one point where this can happen. When tension and velocity both become 0, there is only one point where this can happen. What is that point?
Highest point.
That point is point B. We have just seen point B. That is the only point where this can happen. In this case, that is the only point where this can happen. There is no other point in this universe, in this case, where it can happen apart from point B. That means velocity at C should not become 0, my dear friends, and it should be equal to, and this is what we will prove in the next class, that the velocity at point C is equal to root of GL. And to make this velocity as root of GL, to just reach point C, velocity at point A would be equal to root 5 GL. Now I will give you time to think about these 2 points, and we will discuss these 2 points in the next class. So till the next class, think on these 2 points and tell me why this is so. I'll wind off today's class at this point. I hope you have loved this class, enjoyed this class. If there's any doubts in anyone's mind, you can always reach up to me. I'm always there for you guys. Take care till the next class and see you in the next one. Bye bye.
Okay, sir. Bye, sir.